Good morning, students. Happy Wednesday. We're going to go over day 130 first. And so let's do that now. Yeah. So I asked you. Yep. Okay. I'm in there. So some important things. First of all, how do we get a multi-speed bicycle to ride over any terrain? Changing the gears. So we're going to learn about changing gears today and how that works. So you should have the definitions for these things. Effort force, the force you put in, the resistance force that comes out of that, and then mechanical advantage. Let's talk about that real quick. Mechanical advantage, if we scroll back a little bit, comes from the forces that you put in and the forces that come out. So an example of that, we could pull up your activity from yesterday. And if you looked at the different forces, the forces that the worker was putting into the rope and pulley system and the forces that were coming out, you would have noticed, here we are. So it says here, the force required, it's 1, and then we've got a weight of 1. Cool. And we got a weight of 1. So let's see if we change the number of pulleys. We change the mechanical advantage here. Maybe we give him a few pulleys. You can see the weight of the object is still 1. It hasn't changed, but now the force required is half the weight. And I could use those two force numbers to calculate the mechanical advantage using this equation here. All right, so the effort force is half. The resistance force is 1. 1 divided by half is 2. So this gives them a mechanical advantage of 2, and we actually see that. I don't know why it's not loading, but we see that. Here it is. Here. All right, they calculated the mechanical advantage for us. So that was that part. Let me go back to day 130 here, so we can finish up our review. Hope everybody's doing well. Hope everybody's doing their social distancing. Okay, I'm out. I'm in. Okay, a bottle opener. It's a lever. Let's see. What else? What kind of simple machine? Pulley, right? We went over that stuff yesterday. Greater mechanical advantage would be the 2-pulley system. Why does it have greater mechanical advantage? So it gets to share the movement via 2 ropes. We did. Oh, we're going fast. Oh, wrong picture. So here, this has 2 ropes pulling on it, so they both share the load, which is why the force gets cut in half. What else? Okay, the challenge me questions. Let's see if we have time for those. Oop. What determines how much rope you need to pull? Well, so if we have 2 basically sections of rope, it's the same rope here, but 2 sections of rope here where I'm moving the cursor. Come out. So 2 sections here, then that doubles my mechanical advantage, and it cuts the force required in half. If I put a 3rd section like this, then now it's a 1/3 of the force. You want to say hi? What's you and me, and my students are going to watch this. You want to say hi? No. Okay, hang on. I'm a little busy. So that's the part about rope. Oh, hang on. Nope. How much of the weight of the boxes is supported by the steel girder to which the block and tackle is attached? All of it. It's carrying all the weight. No magic there. And the least effort would be more of these pulleys. Okay, I'll see you later for more video stuff for today.